Good afternoon, students. It's Mrs. Cindy again, and I'm here to talk to you about Nrg transformations and conservation of energy today. So take out your pens and paper, or pencils and paper, I guess, and let's get some notes in your notebook. Okay. So the last time that we talked, we were talking about different types of energy, and one thing that that I kind of said was that the sun, has this energy that comes from the fusion reaction, and it emits that energy, and that's what we on Earth often use for, the sun gives us energy. And so one thing that you may have noticed is that even though it's a fusion reaction, a nuclear reaction, it's giving off some electromagnetic energy, which is a different type of energy. And two of the forms that we talked about of that electromagnetic energy was the sun energy, the energy from the sun, the solar energy, and then also heat energy. And so these are all considered transformations. So all forms of energy can be transformed into other forms of energy. Okay, and this process is called Nrg transformation. And so the example that I used just now was one, but we can turn, like we eat food and we're getting the energy from the bonds within the molecules that we're eating, and that's called chemical energy. And we use that chemical energy to either move us. We also said in the last section that we use some of that chemical energy to keep our temperature warm, so thermal energy. The radiant energy we turn, so that electromagnetic radiation that we're getting from the sun turns into chemical energy that we can then use for food and for fuel, such as like firewood to start a fire and to produce heat and light, which is again electromagnetic energy. That light coming from a log would be that example: heat and light, thermal energy and electromagnetic. We use chemical energy again, the energy stored up in the bonds of gasoline to drive our car, to move our car. So these are all examples of transformations, energy transformations from one form of energy to another. There can be a single transformation, and all those examples that in that last chart were examples of a single transformation, which is kind of, as it said, one form of energy changes into another form of energy. Or you can have multiple transformations, which is when, sorry, not are when, or they are when, a multiple transformation is when one form of energy is converted into a series of energy transformations. So you start with one, and then kind of a whole bunch of different transformations occur. And at the end of this slide, we will look at those, at an example similar to the one that I started this talk on. Okay. One classic energy transformation, and I'm borrowing images from Google Images again, but here is Katniss, I believe her name is. This is an example of potential energy converting to kinetic energy, transforming to kinetic energy. So the potential energy is when she pulls back that string on the bow, I guess is what it's called. When she pulls that back, that's a heck of a lot of potential energy. And then when she releases it and the air goes flying, that is the kinetic energy. So the potential energy here turns into kinetic energy. And I'm sorry that this arrow is not facing the other way. I tried to figure out a way to flip it and I couldn't. So sorry, it looks like it's going in the wrong direction. Okay, so that's an example of potential energy turning into kinetic energy. There are a couple other examples that I want to go through that our book talks about. Another example of potential energy turning into kinetic energy is a falling object. So a falling object tells us that when the height of the ball, okay, decreases, it loses potential energy. And that makes sense. So potential energy is sometimes gravitational potential energy, and the higher up an object is, the higher the potential energy it has. But as the height of the ball is decreasing, as it's getting closer to the ground, it's losing potential energy. But its kinetic energy increases because of increasing speed. And so one question that the book had for you that I thought was a reasonable discussion was, this ball is photographed, so it's saying that it's photographed at equal time intervals as it falls. So every, I don't know, thousandth of a second, something like that, it takes a picture. So picture, 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 picture. How do we know that that the kinetic energy is increasing? Okay, so how can you tell that the ball's kinetic energy is increasing? And the answer to that is the ball is covering more distance in equal time intervals. So it's getting faster, right? It's moving more quickly. So its speed must be increasing, and therefore the kinetic energy is also increasing. So that's another example of one of our classic energy transformations of potential energy turning into kinetic energy. Another example would be the pendulum, and this is why you see pendulums in so many physics labs of people who are into physics, and this is the reason why. It's your classic example of potential energy turning into kinetic energy, and then back again to potential energy. So what this is showing us is that the height of this curve, okay, there is a lot of gravitational potential energy because it can fall. When it does this movement, it's that potential energy is being converted into kinetic energy until it arrives at its highest point again, where it kind of stops for a second, right? And so this camera is showing you is most blurry here because it's moving fastest here, but it comes to a kind of a pause here, and it has high gravitational potential energy. So this pendulum that goes on and on and on, back and forth, back and forth, back and forth, is a great example to show how potential energy turns into kinetic energy, turns into potential energy again. Okay, so a nice, cool example of that. Okay, oops, sorry, trying to click ahead. So here is that example I was telling you about when you have a series of energy transformations, which is again called multiple transformations. They occur kind of when you ride your bike. So this is him riding his bike, sorry, or her riding her bike, I guess. These are all examples of reactions occur within the sun to transform, and so the energy within the sun is that nuclear energy, into, okay, the energy that comes to that plant, so electromagnetic energy. Okay, so the sun's reaction produces a whole bunch of nuclear energy, which is transformed into electromagnetic energy, okay, which is in the form of waves we had talked about. And then plants transform that electromagnetic energy into chemical energy, right? So it goes into the chemicals that it's creating, the food that it's creating. Your body, okay, so we eat this, okay, your body transforms that chemical energy into thermal energy to maintain your temperature, okay, your body temperature. It also transforms that chemical energy into mechanical energy when you ride your bike, when you start moving. And sorry, this is an image of somebody moving right there. Okay, so this would be a great example, and one that I kind of referred to before, of multiple transformations. Okay, now the last topic that we're going to talk about today is the law of conservation of energy. Okay, so the law of conservation of energy. Law of conservation of energy says that, so the actual law itself, here we can change it says that energy is neither created nor destroyed. Okay, so it's constant. Okay, the law of conservation of energy is saying that energy is never created and it is never destroyed. Okay, what we are learning today is that it is conserved. Okay, so energy is conserved and it is transformed. Okay, so one really good example, where do we get most of our energy, right? Where have we been getting most of our energy is from coal, right? From coal, from those fossil fuels. And we know that the ancient animals and plants, when they died, their chemical energy was stored within the remains, and then the trapped energy is the chemical energy that we still use today in coal and fossil fuels. Okay, so ultimately, though, where did that energy come from? It came from the sun, okay, that went into the plants and the animals. Well, it went into the plants first through electromagnetic radiation. It was turned into chemical energy. Humans came along and we ate the plants, and so we got that chemical energy and we converted it into mechanical energy and thermal energy. But we died, and the plants died at some point. Now, I guess humans weren't really around during this part, but the other animals. And so they died. They went into the ground, but it was all that nice energy was trapped in their bodies, in the debris. And so that was still chemical energy that was untapped. It was stored away. So that's an example there. And then one thing to think about is, of course, some things that are moving, okay, they eventually stop moving. And one real reason for this is friction. Okay, friction occurs when some kinetic energy is transformed into thermal energy. And so it's an important concept, is that there's air resistance. There's friction, even machines, even the pendulum, when it swings back and forth, it's creating friction, and that can be converted into thermal energy, so it gets a little warm, those sorts of things. So even though it doesn't look like there's any place where the energy is going to, it is indeed leaving the system. So here's a cool diagram that I'll end with, talking about a roller coaster. Okay, Okay, so here is high potential energy. There's no kinetic energy when the roller coaster is up at the top. As it's halfway down, half the potential energy has been converted into kinetic energy. At the bottom, it has very little potential energy and a lot of kinetic energy. Then it pops up and over here. So again, when it's up on that loop, it gains a lot of potential energy, but it's still moving, so it has some kinetic energy. And then as it goes up and over, it's moving, high kinetic energy and lower potential energy. So suppose you had taken thermal energy into account in the first step. Would the total length of the shaded portion of the bars increase, decrease? So would these be bigger or smaller, the total amount? And it would decrease because some of this energy is being emitted. So it's showing that it's equal. If you were to take this and put this here, or take this and put this here, it would be showing that there's an equal amount always. But overall, we are losing some energy because of the friction, okay, the thermal energy that's being created. Why is the first hill of the roller coaster always the tallest? Some energy is transformed into thermal energy, so the ride does not have enough energy to make it up the hill that tall again. Okay, so thank you very much. Have a great day. I hope you had good notes, and I will talk to you and see you soon.